Use of grass biowaste as a substrate for the cultivation of the edible mushroom Pleurotus striatus. We have introduction, methodology, results, discussion, and conclusions. Introduction. The bioresidue of gardens in urban ecosystems is not properly used and means an economic cost in its final disposal. A sustainable way in its management is to use it as a substrate for the cultivation of the edible fungus Pleurotus striatus, for its degrading characteristics of lignocellulosic compounds, for its growth, for presenting nutraceutical properties, because it has been demonstrated in the prevention of Alzheimer's disease, antidiabetic, for breast cancer, and in general for its antioxidant, anti-inflammatory, anti-cancer, anti-diabetic, antimicrobial, antilipemic, and even immunomodulatory properties. In addition, the substrate used after the cultivation of the mushroom can be used as animal feed, as a soil improper, and/or for horticultural production. Methodology. It is an experimental research of cause-effect where it was evaluated the biological efficiency of 4 different substrates based on the biowaste grass, according to its balance on the C-N relation with 5 replications of each one in the production of the edible fungus Pleurotus striatus, and the obtained data were statistically validated with the arithmetic mean, the standard deviation, and the analysis of variance. The experimental work consisted on the proliferation of the stump on the commercial cultivation means, the elaboration of the seed in barley grains, formulation and elaboration of the substrates, inoculation and sowing on the different elaborated substrates, the harvest and the measurement of the production of the mushroom's fruitful bodies according to the substrate, and finally the analysis of the proximal composition of nutrients of the mushroom coming from the substrate of better production. Strain, the edible fungus isolated from the city of Tingomaria, Peru, and identified as Pleurotus striatus by researcher Ladislao Ruiz Rengifo from the Peruvian Amazon Research Institute. Mycelium proliferation. In 6 petri dishes with the potato dextrose agar, the mycelium of the fungus was shown in puncture, incubated at 25 degrees Celsius for 10 days, and its growth speed was determined in millimeters per day. Elaboration of the seed. A 2 cm square piece of agar invaded by the mycelium of the fungus was placed as inoculum over 500 grams of barley, previously washed, moistened, and sterilized, in polypropylene bags and/or glass bottles. They were incubated at 25 degrees Celsius until the total invasion of the grains. Substrates. To formulate the substrates based on the balance of the C-N ratio, the following formula was used, proposed by INTINTEC, Institute of Industrial Technological Research in Technical Standards. With the data from the analysis of grass and sawdust provided by the Laboratory of Analysis of Soils, Plants, Water, and Fertilizers of the Faculty of Agronomy of the National Agrarian University La Molina, the data of total solids by the Laboratory of Microbiology of the Faculty of Environmental Engineering and Natural Resources of the National University of Callao, and applying the previous formula, the 4 substrates presented in Table 1 were determined. Table 1. Substrates used for the culture of Pleurotus striatus. The bioresidue from the gardens of the University City of the National University of Callao were dried for a month, cut to approx 2 cm in length. The sawdust of the grass were moistened for 1 night, air until only 1 drop was left when whipped and mixed according to the formulation of Table 1, placing 1 kg of substrate in wet weight in polypropylene bags. sterilized in an autoclave for 30 minutes, and left to cool. Results. The average result of the growth speed of Pleurotus acinus on potato dextrose agar was as it is observed in the table 2, where it is noted that the Petri dish 2 and 5 presented smaller growths of 40 mm and 30 mm respectively, and in relation to the elaboration of the seed, after 15 days a total invasion of mycelium was observed on the barley grains. In figure 1, both in bags and bottles, the white mycelium is observed covering all the barley grains. Figure 1 shows a similar stratus on barley grains from 15 days of cultivation at 25 degrees Celsius, in a polypropylene bag and in a glass bottle. In relation to the crops, Table 3 shows 3 waves of harvesting carried out on the substrate with a CN ratio equal to 20.37 with an average production of 91.6 grams of fruit bodies of the fungus. In Table 4, it is observed that the harvest has an average of 121.2 grams of fruit bodies of the crop on the substrate of Cn equal to 30. Table 5 shows the average production of 105.6 grams of harvested fruit bodies from the substrate with a Cn ratio equal to 40.13. In Table 6, the lowest production of 23.20 grams in average of fruit bodies harvested in a single wave of the substrate with a CN ratio equal to 94.12. And in addition, in the 4 tables, the average size of fruit bodies measured in centimeters has been placed, highlighting 9.26 centimeters of the harvested of the substrate S3. With the average production of fruiting bodies of the mushroom, the biological efficiencies were determined, which are summarized in Table 7 and Figure 2, where the influence of the CN ratio of the substrate of the production of Pleurotus acinus is observed, clearly noting that the substrate of CN equal to 30 presents the best biological efficiency, and the substrate of Cn equal to 94.12, the lowest biological efficiency. From the analysis of variance with the data of the production of fruit bodies according to the type of substrate, it was obtained a value of F equal to 10.177 and tubular F of 3.10. Consequently, considering that 10.177 is higher than 3.10, it was determined that the best biological efficiency results with a substrate S2 of relation Cn equal to 30 with a reliability of 95% for the culture of Pleurotus acinus. Besides, the proximal nutritional composition of the fruit-bearing bodies obtained from this substrate, as shown in Table 8, can be highlighted. The high content of water, low content of carbohydrates and fats, and mainly an appreciable content of 8.09% of proteins in human weight or 32.94% in dry weight basis. Discussion. The results of the production of Pleurotus acinus determined that they were influenced by the balance of the CN ratio of the substrate, where the best biological efficiency of 43.44% was obtained with a substrate of ratio CN equal to 30. Second place, 37.44% with a substrate of ratio Cn equal to 40.13. Third place, 32.83% with a substrate of ratio Cn equal to 20.37, and with the lowest biological efficiency of 8.32% with a substrate of higher ratio Cn equal to 94.12. That is the ratio Cn equal to 30 allows the best biological efficiency, and values higher or lower than this value bring as consequence the decrease of the biological efficiency. This result agrees with the review work of factors influencing the cultivation of clitoris by Battistini et al. In 2019, where they pointed out that the balance of 28% to 30% of carbon and 1% of nitrogen is a condition of rapid growth in the production of oyster mushroom, and if there is an excess or low nitrogen content inhibits the growth of mycelium, but in the fruiting stage on low CN ratio is better. The revised research of Clitoris striatus cultivation on different substrates did not consider the influence of CN relation on the production and protein content of the mushroom, except for Ruilova et al. 2017, who evaluated 6 different substrates of CN relation of 33.21, 38.72, 47.99, 57.81, 72.40, and 104.63. And according to their results, they determined that the substrates of CN equal to 47.99 allow the best biological efficiency of 177.37% and with a protein content of 31.13% of the fruiting bodies. Besides, the substrates of CN relation higher or lower than 47.99 presented a tendency to the decrease of biological efficiency. The result of the optimal CN ratio for production does not coincide with the result of this work. However, the authors pointed out that the substrates of CN ratio from 33.21 to 57.81 do not have significant differences in production, and besides, the fact of the tendency to decrease production as the CN value increases coincide with our results. Conclusions. Clitoris striatus strain with an average growth rate of 5.75 mm per day on dextrose potato agar and an invasion time of barley grains of 15 days at 25 degrees Celsius, inoculated at 5% on a wet basis on the substrate composed on 61% of grass biowaste mixed with 31% sawdust and with an CN balance equal to 30 allows the biological efficiency of 43.441% statistically validated with 95% confidence and with a protein content in the fruit bodies of 32.94%. Thank you.